Hey, pre-calc students, Mr. Mitchell here. Today, we're going to take a look at limits. All right, so a limit is a value that a function approaches as the input approaches some number. So the way we read this is the limit of f of x as x approaches c, and then L is what it equals, okay? So there's some conditions when limits do not exist. We will take a look at those as we encounter them. There's three possible ways that a limit does not exist. And we'll take a look at those. If you've seen the movie Mean Girls, the final question, I believe, was about the limit does not exist. So if you've never seen the movie, take a look, go watch it. Has some math in it. All right. So we're trying to maximize our area. So let's say we're trying to make a garden and I got 24 inches of wire, and maybe it should be feet if I were making a garden. But let's just say I'm trying to make something, 24 inches of wire, and we're asked to form a rectangle whose area is as large as possible. So given the perimeter of a rectangle must be 24 inches, find the length in terms of the width W. So here is my rectangle. So here's, I know again, not a great artist, but I think you get the point. So here's my widths. Normally I would just call this L, but I need to put it in terms of W. So the perimeter is 24. So let's try to find our length based on our perimeter and width. So if I were trying to find the length, I would take my perimeter and I would subtract off W and I would subtract off W. So that's minus 2W. And that would give me the two lengths together, but I don't want the two lengths together. I want them separate, so then I would divide by 2. So that is the length of each side. All right. So now we're going to substitute the length expression into the rectangle area formula. So area equals length times width. So it's 24 minus 2W over 2. Times W. So we need to distribute the W to here and to here. This is W over 1. When I do that, I got a 2 on the bottom, multiply across, and then I got 24W minus 2W squared. And I could have simplified it further at the beginning here. I wanted to leave the 2 in so you could see that it was both, we were dividing it to get the single length. But if you now you divide these by 2, our area formula is really 12W minus W squared. So that's our area formula. Okay. So now we're going to come down and complete this table. So my formula is 12 times something minus that something squared. Correct? 12W minus W squared. I put the parentheses in there, and now we just need to change that number in there. Okay, so just to do each individual number, so we do second insert, and our first value is 5.9. We're going to go 5, oops. Messed up. That's okay. So we're going to do 12 times 5.9 minus 5. So we got 34.99. So we can record that value, 35.99. So now we're just going to go change our values. So you just hit second enter, and then you can go in and insert, second insert, another 9 in there. Instead of retyping everything over again, second insert, hit another 9, 35.9999. Right? So for this one, it's 35.9999. Okay. So I'm going to skip over this one since it's a single number. I'll come back to that just for ease of typing it in. So second enter. So then what do we have? 6.01. So this is a 6. 0.01 and a 6.01, and that's 35.9999. Okay, so let's record that. So this one is 35.9999. And let's do it again. So again, I'm doing it this way so I don't have to type as much in. So it's 6.1. And that's 35.99. Okay. Seeing a little pattern here, maybe, maybe not. So 35.99. And then last, let's plug in 6. So let's pull it back up. And all I have to do is delete out the 1 and the decimal, delete out the 1 and the decimal, and then we hit enter, and it's 36. All right. So determine the length and width of a rectangle that will produce a maximum area. Well, so the width is 6, and that means the length has to be 6. So it's actually a square, right? It's still a rectangle, but it's a square. All right. So here's what a limit is. Look at these numbers. As you approach 6, what does it equal? It equals 36. Okay. So the way we could write this, and I know it's not a question that we're being asked here, but I'm trying to make connections here. So we're trying to take the limit as x approaches 6. We're taking the limit of 12w minus w squared. All right, and so you are evaluating this. All right, and that answer is 36. Okay. All right, so let's continue. Let's take this and plug in some values. All right, so we take this equation, 3x minus 2. So 3 times 1.9 minus 2, right? 1.9, okay? And so we hit enter, so that's 3.7. So we're using the table method here to do this. So we'll go back, pull that up, and then I need to insert another 9 there. So 3.97. All right, and now I need to plug in, we can plug in 2, but since I already have 3 numbers in here and I don't have to hit insert, I'll just do 2.01, 4.03. And again, the order in which you do these does not matter. I'm just skipping around here a little bit to save myself some buttons on the calculator to type in. That's the only reason I'm doing this. And then we want to do 2.1 that we're plugging in. So I got 4.3. And then last but not least, I'm going to type in 2. Oops. So then we're going to type in 2 here. So we delete out the other stuff and we get 4. So if you look as the limit, again, if you plug in 2, you do get 4. I understand that. Okay, but what we're trying to do, it doesn't matter what happens right at the spot. It matters what we're trying to do is get close to this number and what happens as we get closer to it. Because of the limit, you may actually never get there. Okay, the example I would use, start at one side of your room and cut the distance in half each time. So let's just say you're in a 16-foot room and you go from 16 feet to 8 feet. And then cut that in half, you go to 4, and then cut that in half, you go to 2, and then cut that in half, you go to 1 foot away, and then cut that in half, you go to a half, a fourth, and so on. And so you'll never get out of the room. I know that doesn't really happen in real life, but there's other things that it does, that kind of does happen. We never actually get there. We get really close to it, but we never get there. Okay. So the answer to this is 4. because, not because you plugged in 2 and got 4, but because you were getting closer. As you got closer to 2, you got closer to 4. Okay. So now here's another question that we're going to evaluate. Again, we're evaluating when we're getting close to 0. So now we have to come up with these values. The first couple problems we were given them. So we would like to plug in 0 to see if it works. We probably need to plug in numbers that are a little bit smaller and a little bit bigger. So how about 0.01 and how about 0.1? And then how about negative 0.01 and negative 0.1? Those are numbers that are close to 0. How close should you be? Close enough. I can't always answer how close you should be. It might change from problem to problem. So we have a number for x. So let's just say that we're doing negative 0.01 divided by, and I'm going to put the bottom in parentheses here. Okay, so I have the top, and then the bottom is the square root of x plus 1 minus 1. So we have the square root of negative 0.01 plus 1, then minus 1, and that's all in parentheses. So again, go back to our problem here and take a look. Okay, so it's all on the bottom, but this plus 1 is inside, this minus 1 is outside. All right, this is on the top, and we hit enter. And we at 1.9, we're gonna have to round at some point. We're not writing out a huge decimal. So let's go 1.9949. How's that? 0.9949. Okay. So then let's go back to the calculator, pull it up again. And for simplicity, I'm going to do 0.01 here. I'm going to get rid of my negative. So I got 2.049. Oh, I wrote that in the wrong spot, didn't I? 2.0. 004? Yeah. Sorry about that. Let me first of all erase this. And I gotta fix that other one. Sorry about that. 0.049. No, it's not writing. Having technical difficulties here. 0. Okay, I think I got some technical difficulties worked out. So 2.049, and then this number 1.9949 goes there. Sorry about that. So let's continue with trying to figure out these numbers. So I'm going to pull this up again. And instead of 0.01, we're going to do 0.1. So 2.0488. 2.0488. And then let's do it again and put in the negative. Now we have to insert a negative. And then insert a negative. And so I got 1.9486. And then we got to plug in 0. Uh-oh. Can't plug in 0. So what does that mean? Does that mean I just messed up? No. We didn't do anything wrong. This is undefined here. Okay. You can't plug in 0. So we're going to go over different methods. One method is to make a table like this. It takes a lot longer to do, but you can't plug in 0. Okay. So you plug in numbers around 0. As you get close to 0, what happens? That's what we're trying to figure out. So these are pretty close. This is 0.1 away from 0. You got 1.94 and 2.04. But then plug in something that's 0.01 away from 0. You get 1.99 and 2.00. It looks like we're getting closer to 2. And we are. If you weren't sure, you could make your table bigger and do negative 0.001 and figure that out. And do 0.001 and figure that out. I'm not going to do that right now. It does equal 2. These numbers would be 1.9999. They'd get even closer. This would be 1.999 something. This would be 2.000, more zeros, and then a number. Okay, so it does equal 2. All right, so now the limit is equal to 2. All right, so now let's use a table to estimate the limit. So we're trying to plug in 1, but if you notice what happens when I plug in 1, I'm going to plug in numbers around 1. If I plug in 1, I get 0 on the bottom. So I already know right now that this is undefined. I can't plug in 1. It's going to be a violation. So I'm going to plug in 1.01 and 1.1. Then I'm going to plug in 0.99 and 0.9. You try to go the same distance on each side. You don't have to plug in these numbers, but you want to plug in something. You don't want to plug in one thing that's over here and one thing that's right here. That's something you don't want to do. So get rid of that problem. So we're going to have a top and a bottom again. So we're going to start with 0.99, and that's cubed. And just trying to remember all the signs. It was minus x squared. So then it's minus 0.99, and we square that. And then it's, and then it's plus 0.99, and then it's minus 1. So again, double check when you type things in. So it's 0.99 cubed minus 0.99 squared plus 0.99 minus 1. And then it's going to be divided by 0.99 minus 1. So going back to our calculator, we close up the top, and then we start the bottom. It's going to be 0.99 minus 1. We close that, we enter. So it's 1.98. This is 1.98. Okay. So now let's plug in 0.9. I don't have negatives here to worry about because being less than 1, you're still positive. So that's kind of nice. So we can go in here, pull it back up, and just go in and delete one of the 9s on each. Instead of 0.99, it's going to just be 0.9. So 1.81. Now we got to do these two values. So we come back to our calculator. And again, it doesn't matter which one you do first. So we got to get 1 point, and then we're going to have to insert 1. Maybe you don't find this easier. I like to do it this way in terms of not having to retype the whole thing in. Some students might prefer just to retype the whole thing. That's up to you. I'm not going to make you do it. I'm just showing you a new method that I would prefer. Now, just make sure you change all of them. And again, it's second insert to insert one thing. So when it's 1.1, you get 2.21. 2.21. And now we have to go in and insert a 0 in our calculator. So we have to insert a 0. Oh, I inserted it on the wrong side, huh? Sometimes that happens. You can just hit delete. and then one more space. So I think I got everything typed in right. Let's type in enter 2.0201. 2.02. So what happens as we get close to 1? What does it look like we're getting close to? We can never actually get to 1. You can't plug in 1. You're never going to get there, but you're getting close to 2. Okay. So if you try to find f of 1, that's undefined. You can't find that. We're plugging in that number, can't find it. But our limit does exist. Okay. So now we just have some other problems that we want to do graphing wise. We can use our calculator, we can do it by hand. Some of them we're going to do by hand, some of them we'll use the calculator. So this first one, a piecewise function, I always like to try to graph it by hand. So f of x equals 2. That's really just y equals 2 and then y equals 0. They're horizontal lines. So we're going to have a horizontal line at 2 everywhere where x doesn't equal 3. So x equaling 3 is right here. So you're going to have a horizontal line up to at everywhere except where x is 3. All right. And then the other function, you have y equals 0 at x equals 3. So you have a horizontal line, but it's only at this place, which is 1 dot. So that's what the graph looks like. So now we need to determine what the limit is. So what happens as you get close to 3? Why is it 3? Because we're trying to do the limit as it approaches 3, this piece right here. So what happens as you get closer to 3? Not what happens when you plug in a value to see plugging in 3. You're not plugging in 3. What happens as you get close to 3? Well, the limit as x approaches 3 is actually equal to 2 because you're getting, as you come left and right, closer and closer and closer, you're getting closer to 2. Again, I know when you plug in 3, you get 0. We're not evaluating f of 3. We're finding the limit of this, finding the limit of this function as x approaches 3, and that equals 2. All right. So down here, we're going to do a graphing question. Let's, we'll come back and do D. So let's, I don't know how B got down there further than C, but it is what it is. So let's go graph some things. So we go to y equals, and we're going to graph 1 divided by x squared. And we graph that. So let's put that graph on our paper. So it looks like this. So what happens as x gets close? So according to what we're going to use, and I'll take 2 different answers here. You can say that it does not exist because it's not approaching the same value. They're going up forever. Or I'll take positive infinity. Depending on who you talk to, they'll give you 2 different answers. You might say, how is that possible? Well, it's depends on your perspective and where it's being applied as to whether you want to say it doesn't exist or whether it's positive infinity. I would say that it does not exist because the way limits are defined, you're supposed to be approaching a value, a finite number. So I would lean more towards this, but if you say this, I'll be okay with that because I know some calc teachers are okay with that. All right. All right, let's take a look at letter B. Show that the limit does not exist. So this is absolute value of x over x. So let's go back to our calculator. Y equals and delete this. So absolute value is under math number. So it's the absolute value of x. And then we have to divide by x. So we graph that. And so we get a line at 1 and a line down at -1. Okay. So my graph looks like this. Open circle here, can't plug in 0. Open circle here, can't plug in 0. 0 is undefined, right? 0 makes the bottom undefined. So as I get close to 0, what happens? Am I going to the same place? No, I'm going to 2 different places. This one does not exist. There's no argument. You can't say, well, nope, sorry, you lose. Does not exist. You're going to 2 different places. Got to be going to the same place. All right. And one more. So let's graph 1 over the sine of x. So first, for anything dealing with the sine, let's make sure we're in radians, and we are. So we're going to have the sine of 1 over x. Sine of 1 divided by x. And we graph that. Okay, it looks kind of like it's getting close down there somewhere. Let's zoom in. Let's zoom in. Oh, well, maybe we need to zoom in again. Ooh. Should we zoom in again? Well, let's do it one more time. See if we can find out what it's equaling. Ooh, oh. It's never going to get there. It just keeps oscillating back and forth. So we never get a limit there. So this one, and you can show like that, maybe with or without the sound effects. So that limit does not exist. Okay, that's one of those cases where the limit does not exist. All right. So again, I would lean more towards this one not existing because they're going, even though they're going in the same direction, they're not going to the same number. Okay, so I would lean more towards this one. I'll take that because I know some calc teachers are okay with that. The other 2 are definitely does not exist. All right, let me know if you have any questions. All right.